Welcome. We are already started the second day of the conference. Thank you to all for being here. And it is my great pleasure today for the plenary session. First, introduce Professor Sumi Elal. You remember, was a keynote speaker in Cagliari and is a very close friend of our community, which will be then the person introducing Professor Chang, who will deliver today's plenary. The title is Software Engineering Research in a New Situation. Please, Professor Sumi.
Good morning, everybody, and thanks, Osvaldo, for introducing me. And I'm pleased to be here in this beautiful city of Hanoi, and I'm honored to introduce a very special person, Professor Chang. So I will introduce Carl formally, but then I will run off a little bit to say a few more words because I know him very well. Carl is Professor Emeritus in Iowa State University's Computer Science Department, and he used to be the chair of that department for quite some time. He's well known in research areas such as requirement engineering, software engineering for situational applications, situational software, net-centered computing, and lately of digital health. Carl served our community very well in many levels. He was the 2004 president of the IEEE Computer Society. And that's when I started to know him. For all that he did, the society honored him with the Richard Merwin Medal Award, that is in 2012. Carl also served in many other roles, editorial roles. He was the editor-in-chief of IEEE Software, the famous publication. And after software, he became the editor-in-chief of IEEE Computer. This is a flagship publication of the Computer Society. And I had the honor to serve under him in the editorial board. Carl is also a life fellow of the IEEE, AAAS fellow, and he is also a life member of the European Academy of Science. But beyond the academic bio, or the professional bio, rather, I would like to just say a few words about Carl and how I know Carl. Carl is very well known in our community as the master planner, the expert that the Computer Society has been using for quite some time. He quietly planned the mega and the flagship conferences for IEEE Computer Society. And nobody could give him the credit he deserved, because I have witnessed all this. He produced significant revenue for the Computer Society by these mega and flagship conferences. So he's known as a master planner. He's also known as the US academic ambassador to Asia. He would do things and forge alliances with professional organizations across Asia in a very clever way and very useful way to Computer Society and other societies in the US. I remember the Information Society, Processing Society of Japan, and how you connected Computer Society with the Japanese for the first time in history. And that produced significant results, the Joint Conference of Saints and others. So master planner, the US academic ambassador in Asia, and one more thing, he's a master mentor. He knows how to mentor a variety of people to success and to career building, myself included. So with that, I will stop here without any further ado, and I would like for all of us to welcome Professor Chang.
make sure this works. Well, very nice to be here. Thank you, Osvaldo, for your invitation, and thank you, Sumi, for a very unnecessary introduction. I told you yesterday I had 90 slides before lunch, so I think let's get it started. The talk is about software engineering research. It's been my career doing research in software engineering and lately in service computing. And from my viewpoint, software engineering and service computing that start getting more integrated, because after all, developing software systems for providing services. So in my title, I said a situation that's singular, but of course, many advances in computing nowadays deserve our attention. So the first situation I would like to mention, although I'm not really a researcher in computer architecture, but I noticed that the recent trend in computing has moved away from Chang architecture, things like neural computing, memory computing, optical, quantum, so on and so forth. That made me to think, well, we started with fundamental architecture. What if we started with something else, like a neural computing? Would that have really helped to propel research in artificial intelligence math in a much faster way? I don't know. Okay, since we are not taking that path in the past, say 60 years. Second situation, that's my research, I begin to notice the tsunami of Gen AI, generative AI. That seems to have made much impact on software engineering research in recent days, recent 5 years, I would say. So it's possible for the software engineering researchers to take advantage of the Gen AI tsunami. Okay. Is that really going to help software engineering research? And for example, can the Gen AI technology support instant evolution of software systems? So maybe we can use Gen AI to define new requirements or emergent requirements instantly. If that becomes possible, what can the impact on software engineers, on the software industry? So much of the talk today is going to focus on this second situation, or just one situation, is between, I would say, how the Gen AI is going to produce impact on software engineering research. Okay, I know many of you here are not in the field of software engineering, but we are all dealing with software systems. We develop software systems and applications. So I think that talk is still relevant to most of you here. Well, I think, as I said, I have 90 slides. Here in this slide, just want to tell you that the revolution cycle for information technology has really picked up very rapidly in the last, say, 100 years. Okay, we started from the spoken language to written language to printing, and now all of a sudden we pick up modern computing, electronic digital computer, and internet of things, and now the AI tsunami. My work, when I started computing, doing computing, I wrote my first Fortran program in 1972. My work is black and white. It's not as colorful as it is. Now we have full sensors everywhere. World is at the center level. And now we're in the Internet of Things era and the artificial intelligence. When I started doing research in software engineering, it's very important. We talk about requirement engineering, life cycle, and all these things. All of a sudden, the world becomes more colorful. Even for people doing software engineering research, it becomes very interesting research area. I, as a faculty of Iowa State University, I feel obligated to set the record straight. Who invented the computer? So here I have 5 minutes to share with you in this talk, and this is the first one. Who invented the first electronic digital computer in the modern day? It's not ENIAC. Okay, the textbook will tell you it's ENIAC by John Markley, Market and accurate, right? These two professors. John Markley visited Iowa State University in Ames back in 1941, summer of 1941. He visited John Tenenza, who was professor of physics at Iowa State University, visited his lab and took a look at his computer. It's called a NASA Barry computer. Barry is his student. Okay, it's called ABC computer. That was fully functioning using 300 vacuum tubes to do everything it needed to do the full scale of computation. His machine, of course, is used for solving simultaneous linear equations. But everything you see on the modern computer today is in that 300 tube logic. It's an amazing achievement. Unfortunately, there was a court case about this ABC. In 1973, after a very long trial, the U.S. federal court, Judge Earl Larson, ruled that NAI is a derivative of ABC. It's not what we said. It's not what Iowa State University said. It's the court, the judge said. Unfortunately, that on that day when the news was, the ruling was made, the news was reported. It happened to coincide with the 15th night massacre. Everybody pay attention to that one instead of ABC computer. Okay, now back to software engineering. Software engineering, of course, you know, the term was coined in 1968, but it's been a long time ago. And people often use this word paradigm or paradigm shift in a very, very loose sense. So how many paradigms have we actually shifted in software engineering or software engineering research? These things like a self-repairing, self-healing knowledge, it is new. Each time we talk about the self something, XYZ, does that mean a new paradigm? Or open source, they bring up a new paradigm. Agile versus planned lifecycle methodology, is that a new paradigm? And so on and so forth. So I think, in my view, my take on the so-called paradigm shift in the modern day software engineering research, I see two very important changes. One is the focus on human-centered. Human-centeredness, I use the word. And the other is the agile method, but it's actual agile. It's not just a Scrum or the agile method we are familiar with today. It's because of the advances in many other areas, such as Gen AI, such as neural computing, and these things. And now we are able to do this in a much faster way in developing new features, new applications in a microservice manner. And that is what I call much agile. But I don't have to do all the much agile stuff. I will focus on the human centered. Paradigm shift. Okay. I came from those schools I mentioned. I did not in the college. I learned this classical mechanics. I never learned content mechanics because that's right at the borderline between classical mechanics and quantum mechanics. So I did not learn, but that's definitely in terms of physics, that is a paradigm shift. But in software engineering, what kind of paradigm shift are we talking about? And in general, when we talk about paradigm shift, we use the Thomas Kuhn's book called The Scientific Revolution, Structure of Scientific Revolution. And that is where he explained in a very clear way. When we talk about paradigm shift, there has to be some anomalies you observe. Then, as crises arise, and then you need to have an in software engineering, of course, as I said, we already talked about software anomalies. It means we miss the deadline, cause overrun in developing software systems, and all these anomalies people observe. Then, remember, there's a term for the software crisis. Okay, and you have anomalies observed, software crisis arise, and then we need to change the way of doing software. Okay, we develop software systems. That is what forces into a so-called paradigm shift. So we can use this working definition, which is pretty much parallel what Thomas Kuhn said. So the paradigm shift means you have to be able to come up with a new law, theory, and practice, and instrumentation in order to be able to do software different sources in a different way, more revolutionary. Here's the second myth. In the second myth, I'm thinking more deeply into comparison between hardware engineering versus software engineering. We know all Moore's law. We know that in every 18 months or 2 years, the density tends to double. How about software? Of course, people say nowadays we have open source repository, software engineering productivity has really improved a lot. But can that compare to the hardware engineers' productivity improvement following the Moore's law? I did a very back to here. Now the Moore's law is for hardware, and I put two software law here. So you know that regardless what kind of language or repository you're using, software engineers' productivity still have not really improved that much, not in any significant way. Of course, when you go component, okay, and the libertary, and then you can do application faster than we're doing since 1968, but we're still not there in my view. I did a very simple calculation back in 2014. In 2014, if we counting start from 1954, if you write I wrote Fortune program as my first programming language. If we can create 50,000 prompts, remember in the old days computers are very, very slow. If we can create, say, a Fortune program with 50,000 prompts, and then in 60 years, from 1954 to 2014, it's already 60 years, divided by 2 years, and then if we follow Moore's law, suppose to create so many 53 petaflops, right? If software and unit productivity can really improve at that kind of rate, and that kind of software, modern software, can be executed by supercomputing in a second. That's a comparison with hardware engineers and software engineers. Okay, of course, the comparison is not very fair, but just get to the point that software engineering really need to improve a lot. So the paradigm shift, I just posed two questions here. Does Gen AI, by the way, I'm not really an AI researcher, but I read all the papers in the functional description level. I think I understand what Gen AI do and how that could help software engineering research. And the second question is human-centered lead to a new paradigm shift in modern day software engineering research. Well, of course, this is the Stanford University AI. AI is not a new term. Okay, why a center is called a human-centered artificial intelligence? There has to be some reason why they choose that name. And the IEEE as a whole is a monochromatic, human-centered perspective of the focus. Why in software engineering research we talk about human-centeredness? After all, as I said earlier, we are creating services for customers, humans. So humans are supposed to be always in the loop. Unfortunately, for software engineering practices nowadays, we talk to customers, we get requirements, and we go back to our lab, we sit down, code, and customers is not in the loop, right? After we have the system, we can UX, usability testing, get customer back in and test, and then we deploy, and the customers in the field. It's no longer directly engaged with the developer. That has to change. And if we can do a much better job there, we will see I would say dramatic increase of software engineering productivity. This is not the most recent survey still says, unfortunately, we're not paying enough attention to human-centered factors, human-centered. Okay, this is 2023, so it's very recent. The conclusion is still the same. Third myth, okay, we have been talking about a lot about self-adaptive systems, self-healing, self-repairing, self-correction, all these things. But does that remove the emphasis and focus our attention from human-centeredness. You look at the literature, lots of papers published in software engineering conferences and journals, they talk about human-centered software engineering. 95% talks about developers' concerns, not the customer concerns. Very unfortunate, because it's easier to publish, right? You got an open source repository, you get all the data there. It's very easy for you to do validation and you publish a paper. That's why 90%, at least 90% of papers published are dealing with developers' concern, and as opposed to the real genuine user concern. UX versus DevX. And now let's talk about situation. I think context awareness, everybody knows about it. And situational awareness, I'm sure you really know what that means. Okay, context awareness is a turning point by Bill Schmidt 30 years ago. Okay, he talked about location. Location is the context in that paper, the first paper. But situation is very much more, I would say, complex idea. Situation, okay, the context could be all identical set. Okay, like Professor Lau, if we all pay attention to a talk and then all of a sudden Professor Lau stand up and walk out the room. And from the context, you don't know what he's doing. You don't know what is what he really want to accomplish. So you have to really understand his motivation, his desire, his term desire, in order to understand what situation. Maybe he just want to go to the best, or maybe he just need to have fresh air. But the way we understand situation has to go through our reasoning, human reasoning. It's not just looking at the country's your environment or human observation. That makes these two concepts quite different concepts. And a human being having to be dealing with such a context. We're dealing with situations, and you get up in the morning, you're dealing with situation after situation. After you understand, okay, after your assessment of all the context, you come with the realization of certain situations. Okay, you see the difference now. Unfortunately, when we study situations, are very complex ideas. Go. This help. Yeah, situation is very common. Depending on who you are talking to. You talk to a logician, that logician has their own definition of situation. Like an event of the whole situation in time, and people perceive situation. Sometimes not just visually, sometimes we perceive through our own reasoning process. And lots of people have studied the situation before in philosophy, like John McCarthy, he actually published Situation Capitals way back in 1963. So it's not really a new concept, and a lot of people in different fields have already studied situation. I have my own take, my own definition of situation, as I will explain in the next few slides. Situation, when we talk about situation, often we talk about desire and intention. Okay, that's the very humanistic term, right? So when you desire, I desire to reduce my weight. That's just a desire, human desire. But you have to be able to take action, right? As future directed concept, you have to be able to take action and commit to it. So I would like to reduce my weight, but I would like to reduce my 20 pounds. All of a sudden, you have a very clear goal to achieve. And then you need to commit and take steps to reach that goal, take actions. So intention is actually a path, right? From your starting point to the goal that to be achieved. So if you're interested, you could take a look at this book to understand better what intention really means. Should come to the computer here. published a few papers and produced at least 10 PhDs in my count in situation awareness. Generally speaking, nowadays, because of the world becoming more sensor-laden, lots of sensors collect lots of data. There are two kinds of knowledge we need to be able to obtain and be able to use in order to reason about situations. One is what I call the permeate knowledge, which is the human, for example, human belief. Something comes from human mind. You believe in something. And then after you see the evidence, here it says experiential knowledge is called posterior knowledge. To be able to reason about situation, you need both. You need both the primary and the posterior of knowledge. My first paper, the journal paper, before that we published in this is a consecutive service computer paper. Basically, the way we formulate situation, the way we define it, is through the triplet called DAE in the bottom here. D means desire. Okay, first you need to have a human desire to achieve some kind of goal, and then you need to take actions, and you also need to observe the environmental context. Okay, so that formulation. And later I use the DAE, I reformulated, I call it MBE, the mental context of human being, and the behavior context of the agent, and then the environmental context. You think about people, the papers in context awareness or situation awareness, there's no exception. You can put it into one of the three pockets. Either it's mental context or it's behavior context, otherwise it's environmental context, nothing else. Okay, you can think about many things. Location is an environmental context, right? And my goal in doing this research is two very noble goals. One is to be able to provide individualized service. This is different from what we normally say personalized service, because in most of the personalized service we are doing parameterization, right? We define parameters, we give a range of values, and then we can say, no, depending on your personal preferences, I provide personalized service. This is much more than that. This is actually individualized to individuals' need. All right, and then every user's mental state can be different. It can never come with a complete enumeration of all the parameters and all the values. How can we achieve that? That's a big question. And the second goal is to be able to really engage human in all stages of the software lifecycle. This is just another view of the MBE formulation, the way I define situation. I use this in the service computing congress. We're going there next week. So from that community, the services are offered depending on the depth of your understanding of these various contexts, different kind of contexts. Especially when you go deeper into the human mental context, it's hidden. You cannot observe it, but can you infer it? If you can find a better way to attack the hidden layer in all these contexts, the better we can provide better service or individualized service to the user. And I have a student did all this very in-depth study on the situation. For example, define the situation session, initial situations. The situation, as I said, is the MBE triple. All right, when you start taking the snapshot of the system, and then you see the user is in this kind of mental state and exert this kind of behavior and the environmental context such and such. Right, so then you start observing, take a snapshot. Okay, in this temporal order, then we have this separation of the situation session. Okay, and from session to session, we talk about situation transition, right? So I think these terms are pretty self-explanatory, so I'm not going to spend much time on this. But more importantly here is we need to understand the two very important concepts. One is called milestone situation, You like to take a shower. Make sure you finish the shower. You turn on the hot water, and you turn off the hot water, and you come out and you put on your clothes. When you put on your clothes, you finish this. All right. So this is a milestone situation concept, and also the milestone transition. We have to transit from one situation to another situation, and that is very critical. You have to go through that step, otherwise you're going to transit to the next situation, things like that. This is just another look at the situation transition. This is another student use this concept to do their requirements engineering work. Okay, so the situation you can talk about multi-thread, because human never do one thing. My wife has one thing. I always do multitask. All right, so we always have a multi-thread parallel situations, and then it transit from situation to situation, and sometimes you cycle back to the original situation. So you got a transition graph like this. And this is very useful for the requirement engineering, be able to define requirements using this kind of transition chart. So if you look at this, the application domain, very often you have to be able to reason about situations, right? And in requirement engineering, we say you have to define situation spec. How do you come up with situation specification? And then the way we do it is we have to reason about how we transit from one situation to another. And the way we do it is really through our knowledge about the world. And unfortunately, the world is quite open. It's quite open. It's not closed. When you're dealing with the human users, even the developers like to make assumptions and work in the closed world. But the users, they are not constrained by your closed world, right? They will do things in your open manner. So when you use originality to do epistemic reasoning, oftentimes we do some things. Like in the closed world, we just do one step at a time in a related fashion, or we look back, or we do a compare and contrast. But in the open world, you often do things unexpected. And that, sometimes I travel and go back home, and the furniture arrangement is so different, right? Because my wife like to move things around. That is unexpected. So to reasonable the situation transition, we have to deal with both worlds. And this is just a requirement engineering, but from observing or reasoning about situation transition, we can do this kind of requirements definition. Just a few weeks. I don't know. This actually goes so yeah. Okay. And when we talk about epistemology, there are many different kinds. The one called our eyes is the Bayesian epistemology. We have about 30 minutes before the launch, so I need to speed up a bit more. So let's keep on coming back. Okay. Anyway, causality. Okay. Judea Pearl is a causal reasoning. I think that's happen to be a very interesting, useful tool for us to study situation transition and cause and effect. And this is just another view because we're talking about the developer's world and also the user, customer's world. And this is another way to look at the developer's idea about how user will use a system has to match the user's world, user's scenario in the user's world. Okay, so this basically shows this is a really classification problem. So in the designer's world, you classify certain transitions in a certain way, and that has to be mapped. There's a reverse function in the user's world that has to be matched. This is called isomorphism in Bauer's theory. That's just another way to look at the situation. I call situationalism between two different perspectives. Of course, there are many ways to define morphism. The reason we need to study morphism or situational in simulation study is because very often, if the temperature rises by 1 degree, are we facing the same situation or different situation? It depends, right? If temperature rises by 5 degrees, if you have a medical problem, that you may face a different situation. But oftentimes, raise the temperature by 1 degree doesn't mean it's a different situation. How do we come to the reasoning assessment that it's a different situation? If we're not careful, it's going to give us a problem. Okay, the system will shift. Okay, I think that's a very interesting concept. It doesn't follow. If we're not careful, only a very small change of the context value or contextual requirements may mean different situations may in the same situation. And if you don't want to have system to think, to believe it's now in different situation and transition to the next situation, maybe because the human mind actually is not that much different. So we need to deal with this particular problem. I call it situational. And how do we deal with this? We define situational very precisely. And in order to do this, first we have to map the situational space. Okay, situation is a space, and many situations in particular application domain, and we map that to the vector space according to the morphism, the computation. This is a very similar situation transition. Is like you browse the web page. Okay, from one page you jump to the next page. It's just like situation transition. Okay, and we have our algorithm able to do this page ranking like of computation in the situation space. And then we publish some papers in that moments. Yeah. Some papers we use an MapReduce in order to accommodate the computation of the situation rank, similar to page rank, compute on situation space, situation vector space. And then we found that actually it's not just a very simple concept in terms of situationism. Actually, when people reason about situation, we do have hierarchical reason. Okay, reason about situation hierarchical. So in order to accommodate human mind in doing this type of situation reasoning, in hierarchical manner, come up with layered similarity mechanism. It's not just one layer. It's like a homomorphism, right? Just on this vector space, another vector space, and we preserve the structure. It's not like that. I think the way we define it, we use many layers involved. And depending on person's preference, depending on how you like to reason about the world. Sometimes people, very careful people, they like everything identical. But for some, depending on your personality, some people say, no, it's more or less the same, it's the same situation. Okay, so this is different. So people reason about similarity, about situation, similarity of differences. Typically, we do that in these layers. And we define different similarity types and metrics. For example, if I have the same milestone, that means you reach the same milestone. Doesn't matter how you reach the milestone, it's the same. Okay, that kind of similarity. And milestone transition, that I said earlier. And then it has to be every step identical. You have to take exactly the same steps. You take a shower in the evening, you always go to the same step. You're not allowed to take a cup of water. Okay, you have to exactly finish before you take a cup of water. Some people think that will make a difference. And the reason we're doing this because if you are facing a new situation, like to you, that's a different kind of situation, and you come with different requirements. If the situation is different, means your desire is different. Remember the DAE formulation. if the desire changes and you are facing new situation, you are going to find new service, different service. If it's a new emerging desire or mental state, you probably need to think how to evolve the system or to provide new service, emerging service. You're not doing that, you're not going to do that by going back to the lab, talk to the customer, going back to the lab, 3 days later come with the new service. You have to be able to do it right on spot. How do you do that? Without going the human state, be able to capture the information, you are able to be able to do, right? So that is the how we improve software engineering ability. If we can get that accomplished, and then we start the software activity provided on-demand service, and to be able to accommodate the new requirements and needs that becomes possible. Yes. This is the way we think we could come out with use a evolution concept to train the system into the end user system. So the end user application chain system becomes the corresponding chains. Okay, so that was here we have so the whole thing is actually it's not just a very simple situation. I mean, it's actually situation awareness. You require situation architecture to be able to capture the contextual requirements, the contextual values, be able to come, be able to intend awareness, be able to do. You need to be able to do a situation in order not to waste energy. Think is differentiation. You need to come with a way to model system provide different services. So it's actually a very complex environment in order to get the whole thing accomplished. That's why I have already invested in 10 PhDs on this, and we are still not set on. Key research issues in how do you deal with human mental state. There's many things you have to do there, including how do you discern a human as a new desire? How do you infer human as intention change? As I said earlier, intention is the path, right? You take an action to the next situation, take another action, you move. So intention is the path until you reach the system goal, achieve the system goal. Now, how do we infer that? Okay, how do you look at the log, the execution profile, and understand the user has changed the intention? The way you user using the system, actually they use for other purposes. How do you reason about that? And how do we learn from other scientific field? I happen to, because I'm helping me to go to this healthcare, I have my own smart lab and looking into all kinds of gadgets. For example, this EEG device. My lab actually looking into 4 generations. And recently I found this EEG device to capture the human brainwave. And from there, you'll be able to interpret the user's intention. If you implant some kind of sensor into your prefrontal cortex, you'll be able to intercept the user intention. And then you understand what the user is trying to accomplish, and you help the user to accomplish that. Okay, for example, a fully paralyzed from head down, paralyzed person, would I be able to drink a cup of water? And how do you use the aroma to get water and be able to capture the intention? Okay, to help the user. That's definitely a very important application in digital health area. And I happened to come across this more recent papers. I then understand actually it's allows new EEG devices out there. It's really beyond what I studied. And we just begin to understand how human export our options, alternatives in our mind because of the advances in psychophysiology study like this. And then how do we actually do one-time service evolution? Okay, you can do many things. If you can infer human desire change, intention change, and so on. And if you can really be able to evolve service in real time, Okay, right in the field or on the fly, you are able to really improve software engineering research and software engineering productivity. Okay, so I have these two factors to consider in that regard. And what kind of tracking we need? We talk about lots of things now, right? Desire, intention, situation, transition, EEG device. If you are programmed, you'll be overwhelmed with all these ideas. So you're not going to deal with each of these elements one by one. You need a much better abstraction to deal with in order to accomplish this. So that abstraction is lead to the next thing. Now the entire computing field will satisfy with object orientation. Everything is object oriented. Is that the ultimate, the final abstraction? I don't think so. I think now we're in the IoT era. We have all kinds of sensors, and all these complex contextual parameters, and we're dealing with contextual requirements. Even before the system is deployed or developed, even, we put the sensors, we'll be able to capture the from the field before you even start implementing the system, right? So in this very complex scenario, what kind of abstraction do you need? Is that object orientation is enough? I don't think so. I think we have already entered the next paradigm, is called the situation-centered paradigm. Okay, you talk to people developing autonomous driving. They're already looking to all kinds of contexts, right? Through your gaze, through sensors, and be able to capture all the requirements and understand what the user is trying to do. So trying to run into a tree, right? You need to be able to prevent that from happening. So people actually already start working on situation game modifications, which are safe. And we don't have a good analysis or framework to do it. I'm here at the poll to one way to do it. This is not my work. This is the work by Yang Kung in his lecture in Harvard University. He said the current Gen AI is sucking. Okay, because it doesn't know how to reason like a human. It doesn't do the planning, doesn't do this well. And my observation is that what people do is one very important foundational concept is model. It's a situation model, I call it situation model. In order to be able to do it. And if two situations are the same or different, then you need to evolve the system. You evolve the service. And how do we do? How do we evolve the service? There are many cutting-edge software techniques really out there, such as community GI, genetic improvement. They already learn how to do without correct errors in the metric. Automatic error correction, right? That in a sense that is involved the software service, right? The software systems. This is what the title of this talk. If you're interested, the system can learn, can remember, can reason, can plan, like a human being. My view is that I think he's overly optimistic. I don't think we're there. We will never be there. No, don't say it, never. Okay, I think it's still a way to go. So here comes the final myth. So Gen AI or through the large language model, this is eventually going to match the human level linguistic ability, capability. Again, this is not my paper. I came across this paper. It's April 2024, this year. In this paper, it clearly describes or explain why the current Gen AI has a long way to go. The Gen AI is very good at informal linguistic capability, but still far away from reach the human level functional linguistic capability. So what's needed in this paper is situation model. Loud and clear, we need to be able to model the situation in this world. And I just took two pictures from this paper of the formal linguistic ability, syntax semantics, right? The form, the sound, and so on. And then the functional capability is much more than that, right? So the social reasoning, model the situation, be able to comprehend the world, the knowledge about the world, be able to do some reason, and be able to plan. You need a situation framework. But I do think that Gen AI can be used in some research, software engineering, development applications. For example, we could generate test case from using Gen AI, right? For example, we could use that prompt to be able to collect requirements. I think Gen AI, although it's not human level intelligence yet, it can help us and to improve the software engineering productivity. But in order to really have leap, it may not be the more slow type of leap, but at least it should be able to do much better than currently what we're doing currently. Yeah, so I'll just give something. And the other thing people are talking about nowadays is that we run out of data. Okay, we don't have enough data to train the generative AI or elaborate mind. Now, what do we do? So people suggest we should do synthetic data generation, generative synthetic data. And here, I think the situ framework, my framework, can help generate situation type of data. Because the data out there does not conform to the way I define situation. So I have to, if I have students, I retire, I don't have students. But I think we can generate a situation, rich data in order to be able to train the system, train AI, be able to understand situation, do situation type of work. Yeah, I think I would like to wrap up my talk by giving you the key takeaways. I think human has to be involved, engaged in all aspects and all stages of software engineering lifecycle. Okay, not just requirement engineering, UX usability test. I think it's there all the time. And then that will give us the enough contextual information, including mental context in real time, and be able to evolve the software services to meet the demand which just emerged in the field. I think that's a very important concept for humans and implements. And secondly, situation has to be more clearly defined and put a human always in group. And how do we automatically refine the system, provide better services? We need to use whatever techniques we have available to solve engineering research nowadays. Yeah, and eventually we need to have a system which can help us to reason and be able to plan. So I don't have a crystal ball to predict what's going to come up. Gen AI, LLM was a very big breakthrough, but has its limitations. Back in 1994, 30 years ago, I predicted in my EIC message, my service software, I predicted something, and then that all happened. The prediction back then is much easier than now. I think it's getting harder and harder. Velocity, who was one of the precise president, he does this annual prediction of technologies. He himself included in the getting harder and harder. So as I said, I come from the old school, from very early days of computing. This is, I entered computing in 1972. I wrote first book before Chang. And then went through all these different kind of stages, both in computing and in software engineering. I think what's coming up on the horizon, I use these three stars here, okay, three very important keywords. First one is from home architecture is rising. And second, I think talking about situation driven. And I use the word, the term seamless computing. It's just there. When you wake up in the morning, it's computing is everywhere, and you even notice that's coming out on the horizon. And finally, we'll be able to offer individual service because much better now in reason about human intention for desired change with the modern technologies. My own lesson, I retired now, right? So I look back in the past 40 years, I do research. I think first thing is to make it simple. The NBE or DAE formulation is not a complex. It's just three triple, but it covers everything. So I have time to be short, but the story is funny. Let me talk about story anyway. There's a group of scientists. They got a grant to do a study on a particular farm field because that farm field can lots of crops, very rich crops coming out from the soil. So they did also a big study and look at everything, analyze the composition of the soil, the water, the climate, everything. And finally the farmer gets retired. Say, what are you guys doing here? Okay? They said, oh, we're doing very important stuff. It's going to help the human being and solve the hunger problem in the world. And farmers said, why is that? But because your farmland produce so much crops. Now we really really want to understand why. The farmers, oh, you should tell me earlier. That's because we're under the electricity pole, and there's some of the birds there. And you know, the bird flu help with the problem. As simple as that. But people sometimes they just overcomplicate the story. I think you get a point on the story. I read in the hemisphere the idea of with Chang. The second is naming engineering. Naming engineering means everybody follow the same trend, like quick diet. Okay, and then one jump off the cliff, the other one by one, they all jump off the cliff. That's what the term means. Don't jump off the cliff if that is a dead end in your research. Thirdly, solution finding problems. In my experience with working with so many colleagues, sometimes I'm really curious why the person tries to use a particular technique to solve a problem which is not necessary. Try to find the problem to solve, but you already have a solution. Okay, for example, the problem I call use a pattern to model software systems. Good pattern model concurrency structure, purpose structure, that's good. But it is modeling all the way to the statement level. If Daniel these model the code, that is okay. Okay, so it has a good solution, but it's modeling the wrong problem. Long is okay. Okay, so here, long is innovation. So if you are working along, nobody is working on a situation, that's fine. You enjoy yourself. Okay, long is fine. Eventually people will pay attention to it. And natural solution may exist somewhere. Okay, it's not necessarily to be all scientific, systematic, mathematics. Sometimes the solution just exists naturally. Look beyond what you, beyond your comfort zone. Look beyond, look into other fields where to learn scientists, engineers from other fields, and generation. Okay, very important. Okay, situation happen to be lead by someone happen to be applicable to all kinds of applications in terms of focuses. Come to the end. So artificial intelligence is that intelligence can you teach right from wrong to the top. And in order to do that, you need to make sure your robot has a consciousness. That's another very hard thing nowadays. Artificial consciousness, but it's not human consciousness, right? Okay, I talked to ChatGPT. You love me. ChatGPT saying you're nuts. How can I love you? I'm wrong. So we're still a long way from achieving so-called consciousness in AI world. And is AI really friend or foe? Some of the references they were interested in just to Google some of my work. And we're only 20 years from arriving at the so-called technological singularity by great customer. 20 years, 2049, was supposed, the world supposed to be taken over by AI. Is it possible? Are we arriving at that anytime soon? Is that a possible situation? I don't know. I already over my time education class now right here. Thank you. I know lunch is coming up, so
really like understanding feature because and I fully agree that that's my opinion. And I completely agree with that. Looking to the nature, to the value, is the simplest way to deploy systems that become clever, become usable, responsive.
Yeah.
Before you focus on the usability of the solution program. Because since the work is becoming more and more difficult, if you are using interfaces that are not usable, you are in the block and you can overcome the situation. It's really important that all software become so friendly, so intuitive, and then actually so thank you so much.
you don't need to overcomplicate the matter. Oftentimes, less is more. I know I throw lots of things I'm hearing short 15 minutes talk, but just go back and think about it, and we can always talk more. Send me an email.
Okay, let's thank Professor Chang one more time.